I am Assistant Vice President Jeongdan of ETRI. I will be presenting in Korean. Thank you. I would like to discuss the software development strategy for autonomous driving service platform. So autonomous driving service platform, our technology, our policies. These are some of the themes that I will cover today. First of all, let me talk about autonomous driving service platform. As you know, robotaxi shuttle buses, delivery trucks, logistics trucks, should all also incorporate autonomous driving in the future. And the platform does the job of incorporating AVs in these different areas. In order to have electronic control of the driving systems, you have these technologies that you see on the slide, and you have sensors on the vehicle or on the infrastructure that transmit and collect information on road conditions, driving conditions, so that you can achieve the driving mission. Especially in electronic control system, you need to have accuracy and performance in terms of the fast response. And also you need to have assurance for the safety of the driving. In order to satisfy all these conditions for the platform, you need to have scalable and flexible specifications for the platform. And there are a lot of issues related to these conditions. In this technology, as we go up the levels of autonomous driving, you require more complex technologies and requirements. One of them is related to the vehicle sensors. At the moment, there's a limit to the scope of recognition, and so you need cooperative system in sensors. And also, in order to do more integrated decision making, you need to incorporate AI algorithms, and especially you need to make it lightweight in order to incorporate the technology in vehicles. In terms of these technologies, we have four main areas of work. Number one, in order to create this autonomous driving service platform in Korea, we have to carry out the performance tests. Number one, can you reduce the speed in school zones? And also number two, can you recognize signals at intersections? And can you actually transmit this information by 5G communications? And can you detect cyclists to stop? And also, do you have the right assistance during traffic jams? And also, can you accelerate when you enter the highway? And also, in Korea, we have these special systems called tolling gates. You have to be able to pass through it the right way. And also, if you have to enter and pass the tunnel or the roundabout, you have to do it right. So you have to pass all of these tests. And secondly, in terms of the service platform, we tested voice recognition command to actually call a robot taxi to get in the robot taxi at the designated area. And when you arrive at the destination, you can also have the auto valet parking service. We realized all of these services. So what will happen if you can call a vehicle to where you are? This is not just something that you see in science fiction. You can use smartphone to hail a ride, and the driving was also done autonomously. This is a man using a smartphone to hail an autonomous vehicle. The vehicle is driverless and arrives right where you are. When a car enters in front of you, then the car automatically stops. And also the car stops at the crosswalk and stops right where the person is waiting. And third is low speed shuttle. On the left, you see a map where 3,000 researchers of our institution work. These are all R&D centers. And we run shuttle buses on demand and on site so that the researchers can use the shuttle bus where and when they want. Also, once this AV service platform is completed, we can provide all the services with the best convenience in terms of timing. And so we use 8K content for streaming the data, and also we use large screens to actually show the timetable. And also we link it with robots, AI, and other technologies to provide better autonomous driving service platform. Lastly, we also made sure that the platform works on laneless roads or laneless areas. In Korea, we have a lot of these roads where there's no lane. And we used AI algorithm to test the platform on these driving areas without lanes. More comprehensively, we have achieved these 5 features, and let me show you a video demonstrating that. This video shows how the car can perceive 3D location of the different objects on the roads. As you see, as the car drives, camera sensor, LiDAR sensor are used to identify road marks, pedestrian areas, and other surrounding obstacles using LiDAR sensors. And the data detected using the sensors create this 3D map of the surrounding environment in real time. And you can see that on this video. As you can see, this is the 3D map that is formulated based on the data perceived using sensors. And next, semantic segmentation is used in our AI technology. As you can see, each pixel has an attribute and creates an image showing the road conditions and the driving conditions. So that's another algorithm that we use. This research project has not been completed yet, but as you can see, we have advanced these algorithms. We've made them lightweight, very responsive, very fast, and within limited resources on the vehicle and on the infrastructure, the algorithms do the best job possible of creating the surrounding recognition. As you see on the right, you can see the categorization of different road attributes, and based on these attributes, the algorithms are used to actually perceive the surrounding. And next is about object detection. LiDAR sensor is used to actually identify moving objects like moving cars, pedestrians, cyclists, etc. So you can actually detect these moving obstacles. Tree objects, so it can be detected in box shapes or 3D cube shapes. You have to be able to accurately detect these obstacles in order to avoid them. And next is about detecting tail lights. As you see, the color of the tailgate, as well as the signals for turning right or turning left, are detected by the camera so that you can actually know in advance what the car in front of you is going to do. So predicting other cars around you will ensure a safety of your own driving experience. So that's another area where we are conducting research. The video seems to go on a little bit too long. We have one more video that I would like to show you. Yes. So the next is about trajectory prediction based on your past trajectory. So that's another application of the algorithm. Now, through various research, we are making sure that this technology can actually be demonstrated and experienced for actual drivers so that we can find our direction forward. Whenever we carry out these tests, we do identify problems that we can resolve, but we have to build on these tests to make sure that we can keep the safety of the AVs and also to make sure that we can integrate AVs successfully on the public roads in Korea. With that as a conclusion, I would like to provide with you the 2 main policies we have for this platform. Number 1 is to create the technology and develop the technology as an open service platform. We use edge and cloud computing that can be synced with the platform using the software platform, and also we have this open service architecture to provide the best communications feature. And next, based on that architecture, we carry out various simulations on cybersecurity and other unknown and intentional attacks so that we have the algorithms to respond to these attacks. And also we make sure that the AVs and the platform can work together with other drivers on the road. Based on these policies, we are going to continue developing autonomous driving service platform using edge computing, cloud computing, And next, we are going to accumulate the data for learning and build up machine learning AI learning data so that we can actually simulate these on real roads as well as mock environments so that we can create a safe autonomous driving platform service. And I will conclude there. Thank you very much.